This is Larry Hatcher, Psych 299 Statistics. This is part 2 of my video series on this mini chapter. We're looking at the mini chapter called Part 10 Variables in Statistics. If you're in my class, you should have downloaded the PDF that has this mini chapter. You should have it in front of you, be following along with me as I lecture on it and adding key terms as we come to them so you can fill in the blanks and have a complete set of lecture notes by the time we're done. We are some distance into this mini chapter. We're on page 10-6. We're talking about 4 measurement scales used with variables in research. A lot of books refer to this as Stevens 4 measurement scales. 4 measurement scales are nominal scale of measurement, ordinal scale of measurement, interval scale of measurement, and ratio scale of measurement. In part 1 of this video series, I went over some basic terminology in statistics and then talked about nominal scale of measurement and ordinal scale of measurement. And we were toward the end of my talk on the ordinal scale of measurement. I give the warning, in general, you should avoid the use of single item rating scales when you're doing research. When your data are measured on an ordinal scale, when you measure something using a single item rating scale, a lot of statisticians, a lot of researchers will worry that the resulting variable is going to be on an ordinal scale of measurement. And if you measure, especially a dependent variable on an ordinal scale of measurement, we have relatively few statistics that we can use to analyze data from studies like that. I advise students in general stay away from variables measured on an ordinal scale of measurement when possible. With most of the things we measure, it's possible to instead measure them with a higher level of measurement, and that is the interval scale. Here I'm going to talk about what an interval scale of measurement is. We'll talk about the fact that we have more statistical procedures that are appropriate if your dependent variable is assessed on an interval scale of measurement. I'm on page 10-6 toward the bottom. What is an interval scale of measurement all about? A variable to an interval scale does indicate quantity. Each score indicates an actual amount. There's an equal unit of measurement between consecutive scores. A good example of a variable that most researchers agree is measured on the interval scale of measurement is IQ scores, where you could have an IQ of 100, an IQ of 90, and so forth. With respect to the underlying construct of intelligence, most researchers believe that the difference between a score of 100 and 101 is about the same as the difference between a score of 101 and 102. IQ has equal intervals. We think of IQ as being measured on an interval scale. Something being measured on an interval scale of measurement is a good thing, but interval scale of measurement is not the highest scale of measurement. We're going to see in a minute that's going to be the ratio scale. Well, what's wrong with an interval scale of measurement? What does it have? What does it not have the ratio scale does have? The one weakness with an interval scale is this. Interval scale does not contain a true 0 point. Although the scale might include the number 1, although a score of 1 or 0, although the scale might include the number 0, this number 0 is not what statisticians call a true 0 point. A true 0 point means that the thing or the person has absolutely no amount of the attribute that's being measured. If something is measured and you're using a scale that does have a true 0 point, and if somebody gets a score of 0, that means they have absolutely nothing of whatever it is that you are measuring. Here's an example of something that's on an interval scale, something that does not have a true 0 point. It's the standard example of something's on an interval scale that does not have a true 0 point, and that is the Fahrenheit scale that's used to measure temperature. Fahrenheit scale is on an interval scale. It measures heat. Most researchers believe that the scores on the Fahrenheit scale do have equal intervals. The difference between the temperature of 70 and 75 degrees is about equal to the difference between the temperature of 75 degrees and 80 degrees, but Fahrenheit scale does not have a true 0 point. If you're measuring something in Fahrenheit degrees, does temperature of 0 degrees mean that there's absolutely no heat present in the temperature? No, not if it's on a Fahrenheit scale. When the temperature outside goes down to 0 degrees, that means it's cold, but it can still get colder. Temperature can go down to -10 degrees. It can go down to -30 degrees. If this was a true 0 point, it would mean that the molecules actually stopped moving around. And when the temperature gets to 0 degrees Fahrenheit, it does not mean the molecules have stopped moving around. So 0 on a Fahrenheit scale is not a true 0 point. Now, I said that interval scale of measurement is a good thing. We're going to see in a minute we have a lot of statistical procedures that you can use to analyze data if your dependent variable is on an interval scale of measurement. Lucky for us, most psychological variables that are created using rating scales and questionnaire items are on an interval scale. Most researchers assume that they are. For example, scores on intelligence tests. IQ scores of 100, 90, 115. Most researchers assume that those IQ scores on an interval scale of measurement. Personality scales. You take personality measurement of the trait conscientiousness. Maybe the scale has been constructed so scores could range from 0 to 100. Higher scores mean you're more conscientious. Most researchers would agree that scores on that scale are on an interval scale. Most attitude scales that are constructed using multiple item summated rating scales, most researchers agree that it's on an interval scale. I'm going to have more to say about this business of multiple item summated rating scales in a minute. Most researchers assume that with variables like this, there is an equal unit of measurement separating each score, but there's not a true 0 point that puts it on an interval scale of measurement. Now, I said that things like intelligence tests, personality scales, attitude scales are often measured using multiple item summated rating scales. What is this all about? The most common type of variable that's used in psychology that's on an interval scale is something that's measured using a multiple item summated rating scale. Now that's a mouthful, but it's not a terribly complex concept. And I spent some time talking about this in statistics class because this is a good way to measure a lot of variables that we're interested in psychology. If you're a psychology student, if you're going to take Psych 305 and conduct an investigation, don't measure your dependent variable using a single item rating scale. Instead, use a multiple item summated rating scale. You're going to see that it's not a terribly complex thing to put together. In our mini chapter, we're on page 10-8. I give you an example of multiple item summated rating scale. For example, let's assume that you're conducting research and you still want to measure this variable motivation to win in a sample of runners. You ask each runner to complete the following multiple item summated rating scale. It looks like this. You give them a questionnaire. The questionnaire has a bunch of items on it. Here's an item. Here's the stem of the item. It's important to me that I win this race. The respondent can circle any number from 1 to 5. 1 means disagree strongly. 5 means agree strongly. You've seen this research questionnaire format often, haven't you? Item 2, we're still measuring the same construct, motivation to win. Here's another item measuring the same thing. I'm highly motivated to win this race. They circle some number from 1 to 5. 5 means strongly agree. I absolutely must win this race. They circle some number. I'm completely committed to winning this race. They circle some number. For a given subject, they can circle any number from 1 to 5. Higher numbers indicate more motivation. Assume that for each subject you do the following. You add together the numbers that the runner had circled, and then you divide by 4 the number of items that constitute your scale. So for subject 1, what did she circle here? What did she circle here? What did she circle here? Whatever numbers she circled, you add them together and you divide by 4 because you have 4 items. The resulting score for your subject could range anywhere from 1.0 if she circled all 1s to 5.0 if she had circled all 5s. Each subject now has one score. Higher scores do indicate higher levels of motivation. I'm on page 10-9. Page 10-9. For a given subject, added together the numbers that she circled, divided by 4. For a given subject, you have a score going to range anywhere from 1 to 5. The scores could have in-between values like 1.25, 3.75, and so forth. With this variable, higher scores do indicate higher motivation. This new variable would be derived from a multiple item summated rating scale. Most researchers would assume that this variable is now on an interval scale of measurement. This is important because many variables in psychology are measured using multiple item summated rating scales. That is a good way to measure a lot of constructs that we're interested in psychology. Attitudinal variables, personality variables, motivational variables, aspirations, and so forth. So, interval scale of measurement is a good thing, but I mentioned before that if something is measured only using an interval scale of measurement, it does not have a true 0 point, and that sets up our next limitation associated with interval scales of measurement. If a variable is measured using interval scale of measurement, although there's all kinds of positives associated with that, there's one negative. It is not possible to make meaningful ratio statements. What do you mean ratio statements? Well, if something is only measured using an interval scale, it's not okay to make statements like a person with an IQ of 180 is twice as intelligent as a person with an IQ of 90. Now, a minute ago, I talked about how IQ is measured using an interval scale of measurement, which is a good thing, but no psychologist would agree that somebody with an IQ of 180 is twice as smart as somebody with an IQ of 90. They know it's only measured on the interval scale. It's not appropriate to make ratio statements like that. It's not appropriate to say somebody that has a score of 40 on the Beck Depression Inventory is twice as depressed as somebody that has a score of 20. If you want to be able to make statements like this, ratio statements, you can't use variables that are on an interval scale. You have to use a variable that's on a ratio scale. That brings us to our fourth and highest scale of measurement. I said that they are ordered from nominal, ordinal, interval, ratio scale of measurement, from the scale that provides the least information, nominal, to the scale that provides the most information, ratio. We have arrived at the scale that provides the most information. A variable that's on a ratio scale does reflect quantity. A ratio scale has all of the desirable properties of an interval scale. The differences between consecutive numbers do represent equal differences in whatever construct that you're measuring, just like with an interval scale. But a ratio scale has something interval scale doesn't. It has a true 0 point. Think of a ratio scale as being like an interval scale on steroids. It has all the good properties of an interval scale and has one additional property, a true 0 point. With a ratio scale, each score indicates an actual amount, is an equal unit of measurement between consecutive scores, just like an interval scale. But if it's on a ratio scale, you have a true 0 point. If something's measured with a ratio scale and somebody gets a score of 0 on that variable, that score of 0 means that the thing or person has no amount of the attribute that's being measured. If something's being measured with a ratio scale then a score of 0 is a true 0 point. Now that might sound real sophisticated. In fact, it's not. We deal with variables every day that are measured on ratio scale of measurement. Some examples of variables that are on a ratio scale of measurement. I'm on page 1010. Example of ratio scale variables. Incomes on a ratio scale of variables. Difference between $5,000 and $10,000 is the same as the difference between $10,000 and $15,000. That means it's got equal intervals, which is good. But income also has a true 0 point. If you tell me that you made $0 last year, that tells me you had no income last year. That 0 is a true 0 point. Number of word pairs correctly remembered. If you give somebody 20 word pairs to memorize and they recall none of them, then that's a true 0 point. They didn't remember any word pairs at all. What's the big deal? Well, maybe to you and me it's not a big deal, but it is a big deal to statisticians, because if something's measured on a ratio scale, then it is okay to make ratio statements. That's why they call it a ratio scale. With a ratio scale, it's possible to make meaningful ratio statements. Length, as measured in inches, is on a ratio scale. So it's okay to say a 20-inch fish is twice as long as a 10-inch fish. Now, why is that okay? Because length as measured in inches has a true 0 point. If theoretically some fish was 0 inches long, then we have no length at all. That means length is on a ratio scale, and it's okay to make statements like that. Age measured in years is on a ratio scale. It's okay to say somebody that is 40 years old is twice as old as somebody that is 20 years old. Now again, although ratio scale is our most sophisticated scale of measurement, there's all kinds of variables that we deal with that are on a ratio scale. I divide them into two categories. In psychology, which types of variables are typically on a ratio scale? I divide them into two families. First of all, physical measurements are usually on a ratio scale. Measuring length in centimeters, that's on a ratio scale. Weight measured in grams. Age measured in years. Time measured in seconds. These physical measurements, most researchers would agree, those are on ratio scale of measurements. The other category of variables that are on a ratio scale is what researchers call counting variables or count variables. For example, number of aggressive acts displayed by an elementary school child in a 20-minute period. You're keeping track of how many times does a child do an aggressive act. That's a count variable. Most people would say that's on a ratio scale of measurement. Number of vocalizations that a bird makes in a 5-minute period. That's a count variable. That's on a ratio scale. Number of word pairs that a child correctly memorizes and remembers. That's a count variable. Most researchers would say that is on a ratio scale. We have one last scheme for classifying types of variables. I am on page 10-11. At the top of the page is just one more example of a count variable, number of crimes committed. Let's move to a new topic. I'm on page 10-11. We have a final scheme for classifying variables. It is the scheme in which we distinguish between discrete scales versus continuous scales. Why is this important? For the same reason that I talked about before with nominal ordinal interval ratio. Knowing whether a variable is a discrete variable versus continuous will help us choose the correct statistic to analyze data involving that variable. We use this information to select the correct statistic. First up, discrete variables. What are they all about? Discrete scale is a scale that allows for measurement only in whole number amounts. Discrete scales may assume only whole number values, such as 0, 1, 2, 3, and so forth. If something is a discrete variable, it may not assume fractional amounts. If it's a discrete variable, it can't give you scores like 1/2 or 2/5. It can't give you decimal values like 1.17, 2.31. These are not examples of discrete variables. Discrete variables, it's not difficult to think of examples of variables that are on discrete scales. How many pets do you own? You might say you own 3 pets, you might say you own 0 pets, but you can't own 1.5 pets. Number of pets you own is not, number of pets you own is a discrete variable. You can only give me whole number amounts. I own 1 pet, I own 5 pets, I own 0 pets. It is a discrete variable. Number of times you've been married is a discrete variable. I've been married 1 time, I've been married 3 times, I've been married 0 times. It's got to be a whole number amount. I can't give you a fractional value. It's a discrete variable. Well, if it's not a discrete variable, if it's a variable that does give you fractional values or decimal values, what do we call it? We instead call it a continuous scale. Continuous scale is a scale that allows for fractional amounts of the variable that's being measured. It's easy to come up with examples of things that are on a continuous scale. Elapsed time in completing a race. Somebody runs a sprint in 4.97 seconds. The fact that you have decimal places there tells us I'm measuring time as a continuous variable. Body temperature. If the thermometer says your temperature is 99.753 degrees, the fact that you have decimal values there tells you that it's a continuous scale variable. If I measure your weight and I say that you weigh 175 2/3 pounds, the fact that I have a fraction there tells you that I'm measuring your weight as a continuous scale variable. That's the distinction between continuous versus discrete variables. One last example. We're still talking about discrete versus continuous variables. But one additional term to introduce, because you're going to hear this term this semester sometimes. The concept of a dichotomous variable. Dichotomous variable is an example of a discrete variable. A dichotomous variable is a variable that has only 2 possible amounts, only 2 possible categories. The dichotomous variable would be something like pregnancy status. You're either in the pregnant group or you're in the not pregnant group. Only 2 categories possible. Enrollment status at a university. You're either officially enrolled or you're not enrolled. There's no 3rd category. HIV status. You're either HIV positive or HIV negative. There's no other categories when it comes to HIV status. Those are all examples of dichotomous variables. At the bottom of page 10-12, I have a little practice exercise for those of you that want to rehearse these skills that you've just learned. I give you variables like nationality. People born in Canada versus people born in England versus people born in Spain. If you take that variable nationality, let's see how we can classify it. Is nationality a qualitative variable or a quantitative variable? You can jot your answer down there. Is nationality a continuous variable, a discrete variable, or a dichotomous variable? Jot your answer down there. Is nationality, what scale of measurement is it on? Is it nominal scale, ordinal scale, interval scale, or ratio scale? That's nationality. I'm going to give you a couple of other variables to play with. Hand pressure as measured in ounces. Baseball team rank. Did your baseball team rank 1st or 5th or what? Pregnancy status. Being pregnant versus non-pregnant. You can take each of those variables, classify them, see if you feel comfortable using these terms that we have gone over. If you're comfortable with your answers, good. If not, you can ask me about it during class when we're getting you ready for the upcoming PAC quiz. This is the end of my video on Part 10 Variables in Statistics. We still have other mini chapters in this unit where some terms are blanked out. I will make available videos in which I fill in the blanks on those. But this is the end of this video, my video series on Part 10 Variables in Statistics.